In this video, we're going to be on page 190 in the textbook. I'm just making sure that we covered everything on 189. We did. So page 190 in the textbook, we're up to a review. And this starts with a vocabulary review, so I'll do that first. I'm not going to copy all of those, but I will read them for you in case you don't have a textbook. Number 1, the set of outputs of a function is the blank. Is that domain or range? It is range. The outputs are the range. Number 2, in a blank, each input has exactly one output. Each input has exactly one output. That is going to be a one-to-one function. Number 3, a blank can be written in the form f of x equals ax squared plus bx plus c, where a cannot be 0. We did not talk about this one, but we're going to soon, so let's go ahead and just put it down. It is a quadratic function. Sometimes these are called second degree functions. Number 4, the set of inputs of a function is the domain. The way I remembered this one, this goes with the x values, which are the independent variables. And I don't know why, but I thought of dominant when I thought of independence. They're not really synonymous, but in my mind, that made sense. So that helped me to remember that the x values are the dominant values in the domain. Number 5, a blank can be written in the form f of x equals mx plus b. That is, let me just write that down. F of x, remember we can substitute that for y, equals mx plus b. This is a linear function. Can be called a first degree function. Let me go ahead and give you the quadratic form in case you don't have the textbook. Number 3 was quadratic. That is f of x equals ax squared plus bx plus c, and a cannot be 0. Okay, number 6, and this is the last one. In a blank, each input has a different output. That is that one-to-one? That's one-to-one. I'm sorry. I got this mixed up. This is one-to-one. They're really close. Number 2, I believe, would be function. And let me just double check this in the back to be sure that I'm not telling you something weird. It's been a very long day, and you guys know how I am anyway. So let me just check this. Range function, quadratic function, domain, linear function, and one-to-one function. Yes, so I made a mistake on that number 2 there. It should just be a function. Okay, let me go ahead and let's look at the skill review. Let's move on down here to number 1. I'm going to try to do a page per video unless it's just incredibly long. All right, we are given 4 tables, and we are supposed to tell which tables are functions and then which tables are one-to-one. So each of these have 5 rows. I'm going to draw this once and I'll copy it so you don't have to sit here and watch me draw over and over. Okay, I can't stand that. This is why I don't use graph paper on a regular basis, because if it's not straight, it drives me crazy. I'm a little OCD that way. Okay, so hopefully you're drawing this with me. Let's set this up, and we have X, and actually no, they call it domain and range. That's fine. Domain and range. And let me just copy this so I don't have to keep doing it. I think I'm just going to go ahead and plop these down so I don't lose one. We need 4 of them, and you can go ahead and sketch yours too. When you write something down, you're activating parts of your brain that are not activated any other way. So you're helping yourself by writing them down. This is Table A, Table B, Table C, and Table D. And the values for A are -3, 3, -2, 2, -1, 1, and 0, 0. So if you want to know if you have a function, remember you look at the domain. There can be no duplicates in the domain. So yes, this is a function. Let me tell you why. There are no duplicates. In the X column. So yes, this is a function. And we can map this function by drawing the lines to the outputs. Or you can simply study the range category, which is your Y, your output section, to see if you have duplicates. Now we've already determined that it is a function, so let's determine if it's 1-to-1. And remember, if it's 1-to-1, there can be no duplicates in Y. So no duplicates in the range, which is also the Y column. So yes, it is 1-to-1. So A is a pretty special case there. It is a function, it is a 1-to-1 function. Okay, for B we have 3, 6, 9, and 12. And then we have 0, 1, 0, 1. So to determine yes or no to the function question, the function test, we saw a graph, we could do a vertical line test, but we don't see a graph. So let's go ahead and look at the column. There are no duplicates in X. So what does that mean? It means yes, we have a function. If you map these values, you can see that both 3 and 9 connect to a 0, and both 6 and 6 and 12 connect to a 1. So this is not 1-to-1, and I'll show you why, or you can tell me why. If you look at the Y column, or the range, the f of x column, there are duplicates. So that means it's not 1-to-1. Okay. All right, for C, we have -1, 0, -1, -2. Then we have 1, 2, 3, and 4. So let's first look at the x column, and I immediately see a problem. Do you see it too? It's right here. We have duplicates in the x column. And if you have that situation, what does that mean? It means it's not a function. And if it's not a function, it certainly can't be one-to-one. Well, I say that. That's not exactly true. This is one-to-one because all the values are different in y. But it's not a function to start with, so we don't have to worry about that. All right. Then we have, it's raining here. 0.2, 0.5, 0.8, and 1.1. And then we have 4 hundredths, 25 hundredths, 64 hundredths, and 1 and 21 hundredths. So in the x column, it doesn't matter if they're decimals or fractions or whatever, the rules still apply. So we have no duplicates in x, so I would say yes, it's a function. And then let's check the y values for duplication. There is none. Nothing is in there twice. No duplicates. So what does that mean? It means it is also one-to-one. So the only one in this set that fails the function test is C. Okay, number 2. I wish I had a copy of this one so I didn't have to draw it, but I don't. So let's put in 4 coordinate planes. We're not going to label them and all that. We're just going to put a graph on them. So let me copy and paste. And I won't have to keep drawing. I should have done this already. You guys know, though, that I'm not very good at planning ahead on these. Okay, the first one, graph A, looks something like this. It's pretty close. Graph C, which is right beside it, that's a little bit confusing. Be careful. Looks something like this. Graph B is linear, but it doesn't pass through origin. It's going to have a positive slope. And then graph D looks like, this is a cool graph, something like that. So let me give you a time to sketch those, and then we'll put this here. All right, now remember, if we're trying to decide if it's a function and we have graphs, we're in good shape because we can use a vertical line test. So I'm going to let a vertical line pass here. Only touches at one spot. That means we have a function. So A is a yes. B, let's put a vertical line. We'll put it over here this time. And it only touches in one spot, so yes, B is a function. C looks a little peculiar, but yes, it's a function. It passes the vertical line test. And D, you'll see it as soon as I draw the vertical line. It doesn't just touch at one point. It touches here and here. So D fails the vertical line test. No, it is not a function. But it's a cool picture. Okay, this is the end of page 191, or 190, so I'm going to stop it, and then I'll meet you back for 191.